Are certain types of sandpaper best suited to specific jobs, or can any type work for any purpose?
Basically, all of our sandpapers you can use on everything.
Okay.
It's not that technically specific. Now the
Hmm.
Ligno, I don't know if Sam showed you the Ligno product or not. That's the
Ah,
first product. That's the first product that was specifically designed for wood
mhm.
and wood sanding. The difference between wood sanding and all the other things that we sand on, whether it's bare metal, aluminum, body filler, anything like that, plastics,
Yep.
is the fiber when you sand wood, like those guitars behind you,
Yep.
and you notice that sawdust, wood dust is bigger than body filler dust or plastic dust. So they designed Ligno because the dust, the particle, the fiber is 1.5 to 2 times bigger. They put the gaps in between those little bow ties that a Ligno disc has 2 times wider, so the dust has a place to get into and get carried away and pushed out through. So you're not resanding that dust over and over and over again, which makes it more efficient and cuts faster and all the rest. But I mean, generally, that's the only one that's specifically designed for a certain substrate. But
Okay.
of course, you're doing bare steel or something hard. The harder your surface that you're sanding, the better quality of abrasive that you should use. That's where you get into the zirconia aluminums and ceramics. And, if you're doing bare steel, you use a silicon carbide, it'll cut great for the first 40 seconds, and then it
Uh-huh.
just runs away.
Yeah.
Aluminum oxide will give you a little bit longer where it'll cut. It won't cut as fast at the beginning, but it'll cut longer. And that's how the ceramics and zircs and all that other grades kind of work.
Okay, so that's a good guideline. The harder the material that you're sanding, the tougher grain you should choose,
That you should
right?
be using, right?
Yeah, like for example, I sometimes I apply polyester top coats on my guitars, which is like the hardest.
Yeah,
Uh,
real hard.
and a silicon carbide won't even touch it. It doesn't do anything. It's crazy. Yeah.
Like I said, for a little bit it'll do it, and then it just goes to nothingness, and then you're
Quick,
polishing over
exactly.
it. Yep, yep. I've been with Mirka for almost 30 years, and I sold a different abrasive and automotive for 12 before that. You don't
Yep.
have to be a rocket science to figure out sanding. It's not that complicated. That's what I try to tell Sam and all the other guys that just started. You know, you
Right.
don't have to be a physicist or anything. You just have to think into it a little bit.
Can you explain the difference between open coat and closed coat sandpapers?
Well, a closed coat is you're stacking as much grain as close together as you possibly can.
Mhm.
And if you're doing something like most closed coats are used for like wet sandpaper because you're using water to clean that out and keep the heat down. A little bit of water, you never feel any heat through that on a metal panel.
Mhm.
Anytime you're sanding, you're creating friction. You're at your you can close coat and use as much grain as possible if you're going to use it in a wet application or something like that. Bare metals that don't want to load up anyway.
Mhm.
And then you go to open coats where if you're doing something real, if you were making a guitar out of pine, which has a lot of sap and things in
Mhm.
it, you would go with open coat so you can scratch it without friction, without putting that ball on there. Like you do a lot of belt sanding, Danny?
Well, a little bit, yeah. Mhm.
But like the guys that make those little drum sanders where they wrap the 3-inch pieces around the cylinder that might be 6 inches, 8 inches long,
Mhm.
or 8 inches big in diameter. Well, that cylinder is going around so many times and has contact with your guitar body or whatever every time, probably 6 times a second, whatever it is, till that thing's rolling around.
Yep.
And that built up a lot of heat. And because it's on that cylinder, it really doesn't give it any time to cool back off again after it's sanded. And then it'll load up in a spot where a knot might be, where you got a lot of resin sticking out at the surface. And then it'll give you that hard patch of stuff right in that line. And then everything that you sand out now has a dent in it.
Mm-hmm.
You know what I mean? Because it's sanded on both sides, but didn't sand where it was loaded up at.
Mm-hmm.
So now the rest of your surface is lower, and where it didn't have any abrasive on it is higher.
Mm-hmm.
So that's why you do the opening coats. I put it on as, I like to think of it as, say you take a 2x4 and you put 4 10-penny nails in it. That would be open coat. And you take that same size of 2x4 and you put 8 nails in it. That would be semi-open coat. So if you put 10 pounds of pressure on the 4 10-penny nails, you're going to get 4 really distinct deep scratches.
Mm-hmm.
You take that same pressure over 8 10-penny nails, you still got a 10-penny nail scratch, but it's probably half as deep. And then when you put 16 on there, like a closed coat, you get 16 shallower 10-penny nail scratches.
Right. Okay.
That's the, I guess, science behind open and closed. So the more open, the cooler it'll sand, but it won't last as long, right? Because if you only have 4 grains of 220 grit every inch, it's not going to last, but it's not going to load. So, you know what I mean? That's that juggling act between how hot or what I'm sanding on how good the paper is going to be.
Ah, beautiful. Yeah, because I'm trying to let's say design the perfect plan for sanding clear coats, which is a nightmare when it comes to when you get to the part of polishing. You see all those mistakes, all those sanding mistakes from the previous sanding stages, and you get frustrated. So yeah.
You look down in and go, well, there's an 80 grit scratch that I didn't take out.
Exactly. Oh my God.
Yeah, I mean, just a basic rule of thumb. When you shouldn't, if you go from 80, you probably shouldn't skip and go to 320, because you're just going to work forever to get to the bottom of those 80 grit scratches. So you skip maybe 1, so you don't go to 100, you go to 120. And you might not do 150, you do 180. You know, and then you go to 240, and then you go to 320 and 400. And
so never skip more than 1. Okay.
Yeah, it as a general rule. I mean, you can get away with it every now and then, especially if you're belt sanding or something. You're going to add pressure to it.
Mm-hmm.
You know, but by hand, it's hard. You work harder than you need to, is what it is, to end up with a good result. It's so much easier. It's so much easier to take your 80 grit scratches out with 100 or 120 than if you would have went all the way to 240 and tried to get the 80 scratches out. You're really, really working yourself to get to the bottom.
At what speed should the sander be moved during sanding?
I mean, we do a lot of training on sanders and application. And if you move the sander too fast, you don't allow it to do what a dual action sander is supposed to do. And that's to cut in multiple directions as the sander's moving. So if you go too fast, you don't allow that sandpaper enough time to keep cutting those scratches, and you get a lot of sand scratches, like you said.
Exactly.
So you want something that you want to go fast enough that you're not, I guess, slowing production down, so to speak. Because if you go too slow, then your manager, your production manager, is going to get rid of you, and you can't go too fast where you have to redo and resand because of scratches.
Mm-hmm.
So it's a moderate hand speed. It's let the sander do the work. You don't have to add extra pressures to it, anything like that. So I don't know. I usually run mine, and I try to tell people somewhere in the 7 to 7,500 RPM. and
Okay.
just enough that you can watch that backup pad. Not You want to put enough pressure on it so the backup pad's not rotating all the way around all the time. You ever notice when you use that sander, it'll rotate this way and then it'll turn the other way and go back?
Yeah.
That's perfect pressure. And you want to go go slow enough that you're cutting what you're sanding on over and over again, so you don't leave those odd scratches out at the edges.
Okay.
So,
Awesome.
So I would love to give you a 1 foot per minute, but there's no real recommendation. You know what I mean?
Yeah, it's a little bit intuitive, I guess. Sometimes,
Yeah,
right?
yeah, right. You're an artisan. You have to. It's a craft. You have to get used to it. It's like painting. You know what I mean? You have the same gun, but if you don't slow down and let it melt back into it, you'll never have a good, solid finish.
Absolutely. Okay, that works. Thank you for that. Okay, so this one is on the technical side, right? What are the key differences between common abrasive materials? Let's say aluminum oxide, silicon carbide, zirconia, alumina, in terms of like hardness,
Yeah,
fractures, toughness.
that's basically the difference, is the hardness of it. Because you could probably get 8 to 10 different aluminum oxides. The whiter it is, the finer it is, so the purer that it is.
Okay.
All right. And then you can actually take it and anneal it. They call it blue firing. So you can take an aluminum oxide and change the properties on how it cuts. It's kind of like tempering a knife blade. You know what I mean? So you want it a little harder on the surface so it cuts like a knife, but you want it pliable in the back end so it doesn't snap and break and become too rigid. But that's the main difference. Aluminum oxide is your standard. It's in probably, as far as sheets and discs, it's probably 70%, 60, 70% all the discs. And then you go with silicon carbide, which, believe it or not, is actually harder than aluminum oxide.
Okay.
On the tensile scale, but it won't stay as sharp as long.
Yep.
They use it a lot in like ceramic clear coats. I don't know if you've ever run into any of that graffiti clear stuff like that on buses, and Mercedes ran it for a little bit on their cars. And when you tried hitting it with 1,000 grit or 1,200 grit to take the texture away, it looked like it was sanding until you wiped it off, and it was just as shiny as what it was before. So that your finish was so hard that you needed a really hard grain to cut into it.
Okay.
And then so you get a lot of silicon carbide for that. Silicon carbide in the wood industry is kind of old school for sealer sanding. People liked it because an aluminum oxide kind of plows in, where a silicon carbide grain kind of chunks out like a backhoe bucket. It takes whatever you're doing away. Now it's finer and shallower than a plowed surface like an aluminum oxide would do. So generally, in aluminum oxide, you can go a little finer than if you're using a silicon carbide.
Oh, I see.
To keep seeing the scratches. Yeah.
Oh, yeah. So based on this logic, would you say that aluminum oxide leaves a deeper mark, right, than silicon carbide?
Yeah. Generally, yeah. If you're doing a 220 on like sealer sanding, if you're using a silicon carbide, it'll actually flow back together, where you have to go to 240 or 320 in aluminum oxide.
Okay.
And if you
awesome.
go into the coarse graded ceramics that are out there, you better go at least 2 for its higher. Because it's not what me, after 30 years of selling abrasives for Mirka, is used to in their mind of what a 320 scratch should be.
Awesome.
Like Galaxy.
Uh, yeah.
Galaxy really cuts, but I'm sure if you played around with it, if you use 320 Galaxy and you did 320 Iridium, you
Hmm.
could actually probably feel and see that the Iridium is a deeper scratch.
Okay. Yeah, I imagine.
Yeah, so if I was using Iridium, I would use 400, 500, something like that, compared to a
Hmm.
320.
Can you explain the types of sandpaper backing materials and how they affect the sanding process?
So your backing's your first base. So you think of it like a house foundation. So a lot of people use paper, and that's pretty much the role for discs and sheets. And the thinner the paper, the finer you have to go with your sandpaper. Like if you were using a 40 grit and you use an A-weight backing, well, the backing's not stiff and hardy enough to support that 40 grit because it's pushing through the back. You know what I mean? You're putting pressure on it as you sand. Well,
Yeah.
just as much pressure is going on to that backing, and if it's thin, it wants to poke through. So your base, your foundation isn't hardy enough to support that. You know what I mean? So that's why they go A, B, C, all the way up to F's, and I mean use the the alphabetical scale to Z.
Hmm.
So most of our papers are a B and a C weight. We have some F weights depending on like belts and things like that.
Yep.
Now we actually treat our paper with a latex coating, kind of impregnated into the fibers of the paper, and that gives it some flexibility. So it can be a stiffer, hardier backing, but still flex, which is why guys went to A-weight papers, because if you did any hand sanding, which in guitar work I'm sure you did, some
Hmm.
people really like that sandpaper to be super flexible so you can get in around where your tensioner knobs are and all the rest.
Right. Yep.
Well, yeah. But then you go to films, and a film's flatter in, I guess, to start with than paper. So when you're coating your paper with grain, the flatter that paper can be, the more consistent level your grain will end up. And with a film,
Wow.
yeah, if you start flat and then you put your grain and everything else on top of it to make a piece of sandpaper, if you started flat, the top's flatter.
Oh, that makes so much sense. Hmm.
Yeah, just like when you go in between coats. If you didn't level out that orange peel and you put another coat on, well, you just made bigger orange peel. And it followed the surface and just made it bigger.
Hmm.
Same thing as when you're building a piece of sandpaper. So the phenolic backings and the thicker, I mean, that's just for the support of generally a bigger grain, a more coarse grain.
Okay.
And then, like I said, then you have films, and then you have the net. I don't know if you've ran into any of the net products at all.
I have tried the Abranet. Yes, sir.
Yeah,
Hmm.
which is it's. I get there's a lot of different things that go into the cake. You know what I mean? To make your paper and make a sandpaper disc do what you want it to do. And you can do
Hmm.
that with some with backing, some with how much, a closed coat compared to a semi-closed coat compared to an open coat of paper. There's so many different variables, and you can tweak it different ways. You can use a less expensive grain if you coat it differently, or use a better backing. You know what I mean? You use a cheaper backing, you can put better grain on and end up with a good disc. It's all in really what you want it to do. Films, you start a little flatter. The netting is as flat as a film disc, but you can only coat it on those little Z fibers that go through, because the rest is air. You know what I mean? You take a look at a piece of Abranet, it's probably close to 40% air. So
Oh, wow. That's a lot.
yeah,
Okay.
yeah. So
Hmm.
you're only putting 60% as much grain on there, and if you get an Abranet that runs as good as a disc, so you're doing all that with 60% of the grain.
Hmm. Hmm.
But it's more open and runs cooler. And if you're doing anything that's sticky and gooey and wants to load up, the cooler it goes, the longer it'll last. So you're not face loading your paper.
Right. Wow. Then the net sandpaper will be ideal for sanding like clear coats, maybe.
Oh yeah, yeah. Oh yeah,
Hmm.
you do sealer. The sealer room at not American Woodmark. Well, they use it too, but for a
Hmm.
different reason. But like York Casket, I think we were getting 7 to 8 to 1 compared to a standard disc
Hmm.
because it was just face loading because wasn't quite cured when it hit their area. So yeah, and the openness of the net allowed it to just keep going without face load.
Yep.
Yeah,
That's
like I said, you don't have to be a rocket scientist. You just have to think into it a little bit. If I'm saying it's
yeah.
something gooey, the more open, the better.
Oh yeah. Yeah. Uh, I get excited about all these small pieces of information because I'm like very nerdy about the stuff. So
Can you talk about sandpaper bonding materials and how they affect cutting action?
You start with the backing, and then they have what they call a maker coat.
hmm
And I guess the easiest way I like to think of it is, you remember when you were a little kid with the mud puddles outside,
hmm
and as they started to dry up, you would like throw stones into them, and they would stick
hmm
or splash. That's what the make coat does. The make coat has to be at a certain porosity and temperature. So when the grain gets bonded up to it, it sticks it straight and doesn't allow it to move. All right.
hmm
So that's your bond coat. And they bring those in different things depending on what you want it to do. And then there's a maker coat, which bonds, goes over top of that, which covers a certain amount of the grain and locks it in so it won't go side to side. So
Mm.
like your foundation of your house, if your walls can move back and forth, same as your grain, well then it's not going to sand as efficient as it should. It needs to have enough support to keep that up with the backing and the bake and the bond coat to hold that up so it's scratching and cutting without bending and flexing.
hmm
So yeah, and there are different ones, and different heats affect it. Like if you're doing a grinding application or you're building up a ton of heat, you want a really solid, strong make and bond coat.
hmm
Where on a disc you can get away with something that has a little more flex to it. You take a 24 grit or 40 grit grinding disc and bend it over, it just shatters
Yeah.
because it's so rigid. Right, but you take a 400 grit paper and fold it over, it flexes better.
hmm hmm
So yeah, that's the difference. Like it's so hard you can't push one thing. You know what I mean? And
Yep.
say this is great. This is what I want to use. I want to buy this. Because it
hmm
does that. Well, then you change grits, and it's like, well, maybe I shouldn't have used that because it doesn't work anymore.
Okay. Awesome.
But yeah,
Yeah. I
that's
was
the difference
wondering.
in the coats.
I was wondering what's that blue coating on the Galaxy, for example. And I use that sandpaper and I sand and sand and sand and I never see loading. It's amazing. So I was like, well, okay, why is that?
Well, it's a new kind of sterate that we use.
Hmm.
It's kind of like a Teflon. So it actually acts. Most sterates, if you're familiar with sterate, that's that white powdery look, or they might
Yep.
they might coat it and make it purple or blue or whatever. But
Yep.
it's always like dull kind of color. Those
Hmm.
are generally self-sacrificing sterates. So when you're sanding on something and the heat's getting built up, it allows that whatever you're sanding on as it heats up, say it's resin from pine, it'll grab that sterate and then the sterate will let go and come off. So the
Hmm.
grain's still there.
Mm.
All right. The new stuff that we use on the Galaxy repels it from even ever sticking.
Amazing. Yeah.
Yeah, so it's pretty new and kind of neat technology anymore.
So it's like a slippery material, I guess. Yeah.
Yeah, it's like trying to put two north ends of a magnet together. You know what I mean? It just kind of pushes it away as compared to letting it get under there and build up heat and then grabbing a hold and then falling off.
Mm-hmm. Mm-hmm.
Yeah, I wish I could tell you how it's done, but I'm not that nerdy. I don't know exactly how it works. I just know it
No,
does.
it's fine. No, it's fine. It's fine.
What guidelines should be followed when selecting sandpaper for hardwoods and softwoods?
Yeah, mostly between hard and softwoods is we talked about the hardness of what you're sanding on the surface,
Mm-hmm.
right? So your hardwood's going to be a harder surface than your softwood, and all your softwoods have a lot more resin and sap, natural materials in it. So if
Mm-hmm.
you're going to sand on softwood, you want to either use a grit coarser because it's not going to load up as fast,
Mm-hmm.
or you get a paper that's designed that more open, like a net that acts more open and
Uh-huh.
runs fuller. And then hardwoods, the biggest thing with hardwoods is you probably have to step up a grit or two, depending on what it is, so you don't see those sand scratches.
Mm-hmm.
Because my general rule of thumb is you don't put a scratch in that you have to take out.
Mm-hmm.
I always go as fine as I can because I don't want to take out those deep scratches in that guitar neck. Like you said, once you put your clear on, you look and you go, there's a few scratches in there because I used this before and I didn't get it out.
Right.
But yeah, between soft and hardwood, I mean, that's the biggest difference. Because once you do with hardwood, or softwood, and get those gum marks, you get those loading marks, like when you do your clear. You get
Mm-hmm.
those curly Q foam cord tail looking scratches, and you're like, well, that's it. It's a 1200 grit sandpaper or a 1500 grit sandpaper that I'm running my clear over. And what is this big foam cord scratch? Is more like a 600 scratch or a 400 scratch. And then
Mm-hmm.
you got to go down into the bottom of it till you get it out.
Oh my God. Yep. Mm-hmm.
So yeah, and the softwoods have more of that resin, and you get those pill marks, those chunk marks, and that just lifts your whole surface of your abrasive disc off, and then it's not cutting. It's you got all the pressure on 5 or 6 pill marks and load marks. So as you're putting down, it is up off, so it's not sanding at the pressure that you're sanding everything else with. And that's when you
Mm-hmm.
change your paper and throw it in the corner and don't like it. It's loaded up.
Mm-hmm.
Makes sense?
Yes, absolutely. Actually, I'm clearing a lot of questions I had in my mind about sanding. I've been doing this for a long time, but I still get some issues sometimes. So, yeah, I'm learning a lot. Thank you very much.
Can you explain self-sharpening abrasive grains?
We do that in the ceramics now.
Mm-hmm.
And instead of it being like one stone, one grain being natural, because it's man-made, they can cluster it up. So it's made of smaller particles bonded together to make that size grain. So what happens when it heats up and builds up, with that friction, it'll knock a chunk off of it and leave you another sharp edge. Yeah, so it knocks, instead of rounding over like a regular aluminum oxide will, it'll actually refracture. It gives you a sharp edge again. And
Ah,
all
beautiful.
that's based on pressures and heat. So
So this means a longer life, right?
longer lifespan, quicker
And
cut.
and I guess the downside is that because it's such a brittle material, it doesn't last longer. I guess, or no, sorry, it doesn't sand as aggressive as aluminum oxide.
Yeah, I mean, it depends on how you put it together, but generally it's actually a little more aggressive than most aluminum oxides. That's where you get all that plus grading from.
Mm-hmm.
And it's just it's coarser altogether. But it'll
Okay.
stay sharper longer. If you're used to using a silicon carbide or an AO, it has that certain time that it'll cut and cut and cut, and then next thing you know, you don't see the the dust as you're cutting, so you end up pushing it harder and harder to get it to cut. Where the ceramics stay a lot more even longer because of its self-sharpening. Because it's not dulling out as much. As it starts to dull, it'll break off and more sharp points come out, and gives you a longer, more consistent scratch. So, I mean, it's generally on a little bit coarser in most of the ceramics and the self-sharpening. At least to your eye, it is. I mean, it's hard to judge what a sand scratch is on wood as compared to metal. You know, you get a profilometer, you can read how deep it is and how hard it's scratching for how long before it dulls out. And on wood, it's very difficult because you have the grain, and you know, wood's just not flat to start with.
Okay. Awesome. Amazing. So if we wanted to design a system, right, using Mirka sandpaper, of course, for a two-stage paint job, let's say on a guitar, which is preparing the wood for applying finish, and then sanding the clear coat up to high gloss. Which products from your whole line would you choose to prepare the wood and then to sand the finish?
To sand it clear. I
Yeah,
mean, when you start, what's the courses that you go
on the wood?
Yeah, like on these or your necks or whatever you're sanding on.
In the past, I went up to 320, but then I learned that adhesion of the sealer is compromised when you go that high. So I'm doing 220 now.
Do you start with an 80, or do you start with like 100, 120, somewhere in there?
Yeah, I started with 100. Yeah.
Okay. So your tooling's pretty good, you know, for your guitar body. Yeah, I mean, I would probably use Ligno myself for the bare wood.
Okay, Ligno from 100 to 220, right?
Yeah, from 100 to 220. You know, that because it gives you a super, you almost get like a 3D effect. It's really nice because you're not sanding over top of everything that you've already sanded. So you get a real consistent scratch when you end up at the 220 or a 240. Okay. And then when you go to put your stain onto it or your color, you're good to go. And then sealer sanding, you can use anything from, I mean, the Ligno works. The Galaxy works really well.
Okay.
The Iridium's good too. Like I said, but you might have to tweak your grits up a little bit because it is more open and sharper. You know what I mean? Because of the ceramics and the way it is. Same as the Galaxy, but the Galaxy seems to be really finished.
Okay, so far, Ligno to prepare the wood, either Galaxy or Iridium to sand the sealer, and then let's say we applied color and clear coat, and it's all dry. It's polyurethane, let's say, right? Polyurethane or polyester. What products do you recommend to?
I like the Galaxy and the gold film myself.
Oh, the gold. Interesting.
Yeah, the gold film's a really nice product too. But I mean, so is Galaxy, and Galaxy you can get from 40 to 2,000 grit. So you don't have, you know, to buy different 600 grits or 400 grits and have 9 different boxes of product out there. But no, they both work really well. And like I said, when I'm done, I don't want to put a scratch in I have to take out. So I like to go as fine as possible. So whether it's a 15 or a 12, that's that give and take between how long it's taking you to level that clear out. Because if I can level it out fast and efficient with a 1200, why would I go with the 800? You know, because that's an 800 scratch that I'm now going to have to buff back out. So yeah, that all depends on the hardness of your poly and how much texture you're taking out or dirt.
Right. Okay, so gold and galaxy, interesting. Then when we go above 2000s, what would you recommend?
Then I always hit it with the Abralon.
Avalon, yes, sir.
Yeah, a little bit of damp sanding, and that just takes your buffing time,
Hmm.
considerably down. All you're doing at that point is refining scratches. It's as level as it's going to be. All you're doing is taking as many of those odd scratches out. So when you hit it with the buff pad, you don't have to buff. I'd rather sand than buff myself.
Exactly. That I prefer that. So I leave very little work for the buffer. Hmm.
Yeah, yeah. You can take your Avalon all the way up to 3,000 grit or
3000,
4,000
correct.
grit, and then you just kind of show it to the buffer and it goes away.
What tips do you have to prevent clogging while sanding?
Well, yeah. I mean, on the Bearwood, even if I'm using a sander and a DA or random orbit,
Hmm.
I still like to go with the grain. It might be because I'm an old time wood guy. I really hate to sand across the grain, but I do. But when I'm done, my last pass is always with the grain.
Hmm.
I have no idea why I do that, but I do. But as far as that, I mean, if you see, sometimes you go too fast with just the speed of the sander. The
Yep.
faster you're going, the more times that sandpaper is going across whatever you're sanding on, the more heat you're going to build up.
Hmm.
And heat's the enemy, no matter what you're doing when it comes to sanding and
Hmm.
finishing, even buffing. So you want to kind of stay off of it, go as low a speed as you can, that you're still not gouging in or anything like that. You got to
Hmm.
go fast enough that it's going to sand, but not so fast. Some of those guys really like to run their sanders wide open, and they're not really sanding any faster. And all they're doing is getting the ability to build up heat and
Hmm.
make scratch marks and swirl marks and everything else.
Hmm.
So,
Hmm.
but yeah, and the same basically applies once you put your finish on it. If you had to stay in a spot because you had a rough area or a defect you had to get out, I go on it and then I'll go back over and sand something else for a while and let that heat dissipate before I have to hit it again. So
Oh,
that's how I
okay.
keep from loading up as much.
So stopping, it's a good, let's say, approach to avoid the heat. Hmm.
Yeah, yeah, that and I always clean it off on my pant leg or a rag, or some people use a piece of carpet. Especially when they're clear coat sanding. When they're hitting with the 1200,
Yeah.
because that's such a fucking grit, and you're asking it to take out that orange peel. If you stop every now and then and run it, keep it clean, that keeps your sandpaper lasting longer on your.
Yeah, you clean it every now and then.
Yeah,
Hmm.
sand a little bit, clean it, sand a little bit, clean it. That way you're not driving any of them pigtails in if you can't help it.
Hmm.
But
Yeah,
yeah,
yeah.
that's it. And like I said, when I use Abralon, it's moist sanding. I don't use a ton of water, and nobody wants a ton of water inside the, you know, bare wood on the edges. So you want to tape those off, and it's it's just enough water that allows that sponge in the back to kind of capillary motion. You know what I mean? As you push it, it pushes the dust and what you sanded on out, and as you take the pressure off, it sucks it back up in. So it kind of
Mm.
keeps itself clean as you go.
Interesting. I was going to ask you like how much water is recommended when wet sanding, you know? Hmm.
Yeah, just a tad bit. You don't need a lot, but you need enough that it's not dry, but you don't want extra where it's throwing any water around either. I give it a
Perfect.
few pieces on the backside, especially if it's a new one, a few
Hmm.
on the face, and maybe one or two on the surface, and you're probably good for the size of a guitar
Hmm.
body. Yeah, you'd probably be good from that point.
All right, guys. I think that was just amazing. We covered a lot. I think people will learn a lot from this video, and I really appreciate your time.
Appreciate it. Thank you, Danny.
Ryan, thank you very much. Thank you, Sam, for putting together the interview.
Absolutely. You're very welcome. Have a great day.
Ryan, you guys have a good one. Thank you. Bye-bye.
You too. Bye.